Okay, how about some with fractions? And these are going to be more challenging. So we have something that is made up on the left side of a mixed number. And I'm going to use the word amateur. When I use the word amateur, what I mean is that mixed numbers are challenging to work with in algebra. The better way to go about things is to go the improper fraction way. And the reason it's better to go about it the improper way is that later on you'll find yourself canceling different values out in multi-step equations. And that's just not totally convenient and simple to do when you have mixed numbers. So here's 2 1/4 equals 1/2, which I've rewritten in my assignment spiral book or whatever it's called. And before you even do this problem, you need to find some space off to the side to do a conversion. So here's 2 1/4. I'm making it off to the side, and I know that 2 times 4 is 8, so I'm going to get 9/4 when I convert that. You also have a calculator that will do this for you. So in this first step, all I've done is rewritten my problem where everything has improper fractions. Now, if you want to, you could take this and change it to something involving fourths. I won't. And I'll say one more thing. Notice that when I rewrote or converted a part of it, I'm not doing any algebra yet. You don't want to mix the rewriting and like the converting steps in the same part because it increases the likelihood that you'll make a mistake. Now, if I were to talk at length about fractions now, this video could be longer. But I know that I got a couple options. Well, if I multiply this by 2 and that by 2, I would not get rid of my fraction. On the right side I would, but not on the left. So the whole deal here is I want to multiply by the least common multiple. So if I take both of these sides and multiply them by 4, I can kill this fraction. I'm going to do this 2 ways, so let's just focus on this first way. 4/4 goes away, and I'm left with 9g. 4/2 is still present, but when I simplify that, I have the larger number of 2 up top. The opposite of multiplication is division, so I'm going to divide both sides by 9. And if space is tight, this is okay. I can write g is equal to 2/9. 2/9 can be written like that. It cannot be written as 9/2, that's for sure. But also make sure your slash is directed in this way and not that way, because that's peculiar looking. It's not what is conventional. Now before I show you the second way, let's box this. So I have 2/9, and then when I go to plug this back in, you should probably do this in your calculator using the original one, but I'm going to use this converted one just so you can see the math. But yeah, I strongly advise using the calculator there. So here is 9/4, because I could have made a mistake in the conversion process, times 2/9, hopefully being equal to 1/2. 9/9 goes away, and 4 is twice as big as 2, so I'm left with 1/2 equals 1/2. Okay, let's check out the second way. Okay, now we've already converted this, so let's keep that as 9/4g. You don't have to rewrite this one, and 1/2. Well, actually, if you want to, you can. Now, instead of multiplying by 4 and then dividing by 9, I can do this in one single step. I know that 9/4 times its reciprocal, 4/9, will give me 1, because 4/4 goes away and 9/9 goes away. So I can cancel out the fraction on the left, so put parentheses around both sides, write 4/9 on the outside with a times symbol, and for this in-between step, I'll make this optional. Here's 4/9 times 9/4 times g is equal to 1/2, which is also, thanks to the distributive property, getting multiplied by 4/9. Now here's why I say this step's kind of optional. I wanted to write this just to help you see that the 9's and the 4's cancel out, leaving you with only g. A lot of people can see that automatically. Well, here I have 1/2 times 4/9. 4 is twice as big as 2, and when I do it this way, I also get 2/9. And unlike the last step, where I did this a different way, where I had to keep on writing, I could have left this out almost and had a simplifying step. We would have used a lot less space. So knowing that, on this problem 2, let's look at 3/5 k equals 6. I could multiply by 5, but I won't. So put parentheses around the entire problem. Now notice that I'm limited on my room here. So for clarity, this time I'll write times something over something. Well, is it going to be 3 over 5? In which case I'm doing 3/5 times 3/5? Well, no, because that would be 9 over 25. That's not going to cancel out. So I think it's going to have to be its reciprocal, 5 over 3, which is just the flip version. I'm using that word like it's fresh to you, but I think you're picking up on it. And these cancel out, leaving me with just 1. So I'm going to multiply the reciprocal of 3/5 by the entire thing, so I'm going to write 5/3. I know that k becomes on its own, because those two cancel out, and I'm left with 6 times 5 over 3. Now notice the way I've written that. I've written 6 taking up the entire space times 5 over 3 packed up right here. That's clear to me. It's clear to me that if I did have a fraction, I could tuck a 1 under 6. And it's also clear that I'm not doing something strange like 6 times 3 over 5. That would be, under 5. That would be way off. Now 6 is twice as large as 3, and I will save time by canceling out in this first step, because now I just have k is equal to 10. Now that didn't become huge numbers, but if I did not cancel out, I would have had 6 times 5, which is 30, and then 30 divided by 3, which is 10. And usually when you cancel things out, it avoids larger numbers, and it makes the math more simple. But you have to be a little confident with fractions. So now I got to check these. 3/5 is in the original problem. I multiply that by 10. Hopefully that ends up being equal to 6. 10 is in my numerator, even though it's not represented that way. And I can slash through it because it is twice as big as 5. Since the larger option is in the numerator, I write the 2 up there. If you like, you can write a 1 down here in the denominator. I choose not to. And then I have 3 times 2 as I scan with my eyes and see what numbers should be located in my numerator. And I get that simplified to 6. And 6 does equal 6, and I can check that. Let's move on to number 3. It's in reverse order. Yeah, we won't make this an OYO. Okay, put parentheses around it. The reason I'm putting parentheses around it is because, again, I have a fraction in front of my variable. Well, 2/3 is in front of there. So I need to multiply the entire deal by 3/2. Now that means that on the left side I have negative 1/4 times 3 over 2, because I have to multiply the left by the same value, and that's going to be equal to 2/3 times 3/2, which becomes 1, so I only have b on the right side. I'm looking, and can I cancel anything out with 3? No. Can I cancel anything out with 2 or 4? No. Yeah, 4 is twice as big as 2, but these are both in the denominator, and they have to be above and below each other to cancel out. So here I get negative 3 over 6, over 8 is equal to b. And because of the way I've done this, I should write it a last time where I have b as negative 3 over 8 and box it. I avoid showing slashes like this until the final simplifying steps because I know I'm not going to do any algebra with it at this point. But if I had slashes up here, it would look peculiar and throw off my work a bit. Okay, now I move on to the check. Negative 1 over 4 is equal to 2/3 times negative 3 over 8. 3 over 3 cancels out, so I'll have negative 1/4 being rewritten on the left side. 2 over 8 cancels out, leaving me with 4 here, and I scan through the numerator. I see a negative, and I know that that means it's negative 1. I had no other numbers to write up there, so I had to place a 1 there. And then the only thing I see in the denominator is 4. So we verified that this is correct. Do problems 4 as well as 5 on your own. I'm going to put the answers up in just a few seconds. In problem 4, I figured out that h is negative 8. And the check works out just fine. Now, if you were in such a habit that you put parentheses around this, that's fine. It doesn't matter. Just make sure that the end result ended up being the same. Let's move on to number 5. Here you go. The only thing that might seem weird about this is that, 7 over 7 is 1. So that does simplify to 1. Sometimes that can throw people off, but there's not too much going on. It also might have seemed weird at first because you just had 1 by itself. But keep in mind, it's what is going on near the variable that drives what you choose. So don't even look at this. You would know, I just multiplied by 7. Oh, cool. I'm good. I'm done. We will not bother putting a 6th problem. I think you've had enough of these, so this will be the last problem for these notes. Now, fractions are going to push you to the next level of difficulty, so ask questions as you come across them, play around with them, talk to neighbors, talk to your teacher, figure out how to do these.